Okay. Okay, so chapter 4, writing classes, and I just discussed why we are doing this, right? Because you think about it, we have a string class. You went to the Java API. We have many other classes that have been written for programmers, so you can use them. However, there is always something that you don't have there. There is always an object that is not written for you yet, or if it's written, it doesn't fit your need. So you need to write your own class. Okay, that's what we are doing here. So we discussed this. In this chapter, we are going to discuss class definitions, instance data, encapsulation and Java modifiers, etc. Okay, you can read that. So that's what we will discuss. Okay, so we will talk about anatomy of a class. What is composed? What does a class, or what is a class composed of? Okay, so I will let you read because, you know, me reading it and you reading it is the same. I will let you read and I will explain it. Okay, everybody. So we up until now, we have written programs with just one class. And that class must contain the main method. Why? Why do we have to have that main method there? Anyone? Because that is the beginning, the starting point. So your program really, your system, your project, okay, if you run it, it starts running from the main method. That's the entry point. Okay. So we are talking about true object-oriented program is based on defining classes that represent objects with well-defined characteristics and functionality. Okay, so these are the two things, characteristics and functionality of a class. So let's look at this. So what is a characteristic? Well, if you look at a student, okay, what are the characteristics of a student? I will just assume you have read all this, okay? So what is the characteristic? One characteristic of every student is each student has a name, and each student has an address, a major, a GPA, a balance due, a phone number. You know, those are all characteristics, and we also call them attributes. They are the same. Properties, attributes, characteristics, they are the same. They are interchangeable. Okay, so these are the characteristics of a student, right? And for a rectangle, how do you define a rectangle? You know, when you talk about rectangle, what immediately comes to mind? Length and width, right? So those are the characteristics of a rectangle. And some of you, what else do you think about? Everybody, when you talk about rectangle, what else do you think about?
The area.
The area, right? Yes, you think about the area. But when you think about the area, think about how you calculate the area. You calculate the area using length and width. So the basic, most primitive characteristics are length and width, right? Because area is something you can get from these two basic characteristics. So we call area a derived attribute. Okay. And aquarium, what is it made of? How long is it? How wide is it? How high it is? So these are the characteristics that define an aquarium. And think about flight. You take a flight. What do you think about? How do you describe your flight? You will say origin, destination, departure time, arrival time, capacity of the flight, etc. Right? So those are an airline, which airline it is. So these are the characteristics that define an airline. Attributes, characteristics, and properties are interchangeable once again. And we call these state. The state, okay, here. Oops. The state of a rectangle, that is its current state. Okay, its length is 10, width is 10, for example. That is its current state. In the next state, tomorrow you have a rectangle, it might be smaller. Its state might be 5 by 5, right? The current state, it's just, I was thinking about the State of the Union, for example. You know, how the State of the Union, you're talking about the financial situation of the country, you're talking about the economy and the foreign policies. Those are all the attributes. And then what is the current state? Currently, you can say our finance is good, our economy is good, the jobless claims, etc. Those are the characteristics of the State of the Union. But what are the current values of them, right, for them? So the current value is either the economy is good, it's neutral, it's bad. Those are the current state. So that's why we call attributes state also. Okay. And any questions so far? So let me ask you, okay, you look at this, you describe a student, these are the characteristics, right? You describe a rectangle, these are the characteristics. How do you describe this? What are the characteristics of a square?
All sides are equal.
All sides are equal, but if you define it, think about when we say characteristics, we are talking about noun, right? A noun that can represent the characteristic of that object. So what is the characteristic of a square? Everybody? How do you describe a square? Yes, all sides are equal. So what is the one thing that can represent a square? For a rectangle, you have to have a length. That's not enough. You have to have a width, right? For a square, how do you define it? How do you describe it? It's the side, right? You just need to know one side because, as Daniel said, all sides are equal. So you see, that's the difference. Of course, you can say a square is a subset of a rectangle. That's absolutely true. But if you just look at a square, what is the characteristic? That is the side, just side. If side is 10, you know all sides are 10. But for a rectangle, it's different. It has to have two characteristics. That's length and width. Does that make sense, everybody?
Yes.
Okay. Let's think about another thing. Think about a professor, okay? A professor. What are the characteristics that you can use to describe a professor?
They're major.
Experienced.
Name?
They're major.
Major or field of teaching, yes. And?
Age.
Age, yes. And student, you know, you have age also. Yeah, that's how you describe a professor or a student or any object. You think of the relative, useful characteristics. Think about a student. How many characteristics can you have? Many, because you can have name, address, major, GPA, balanced due, home address, school address, and part-time, full-time, And what else? Eye color, height, all those are characteristics. But when you define a system, when you want to write a program to accomplish a task, you choose those characteristics that are useful. You discard those characteristics that are not relevant to your project. For example, if you just need to have a student in your database, for me, okay, for example, if I'm using a student object, do I need to know the student's eye color? No. But for a FBI database, they may need to know the eye color. For a driver's license object, the person's eye color is one of the attributes, right? But for me, I just need to know the student name and the student email and the student's grade, you know. So the characteristics are many, and you choose the ones that are relevant to your project, to your task. Does that make sense, everybody?
Yes.
Okay, because in Java, everything is an object. You don't have anything outside of object. That's why we said a Java program is composed of a class. A class is the cookie cutter. A class is the blueprint of an object. So in Java, every program is composed of one or more classes. A class is composed of state, which is the instance state, which is the properties, and behaviors, methods. So, and a method is composed of states. Everything in Java is an object. You never have something that's not an object outside of a class. You don't have anything that's outside of a class. Okay, let that register in you. So now, suppose we want to write something about a library. We want to design a project, a system for the library. And think about it. What do you have to have for a library? I'm not going to ask you about the attributes. Okay, let's just think. A library has to have books. So we need to represent the book as an object. What are the characteristics of a book? How do you describe a book?
Pages.
Danny?
I said pages. Need pages.
Pages. Okay, number of pages is one characteristic of a book, definitely. Anything else?
Subject.
Subject matter, the genre, right? Oh, yes. Not just genre, subject matter. You're right. Genre is for fiction more. Okay. What else?
Author.
Author. You must have the author, right? You must know, this book is written by whom? So author. What else?
Cover.
Cover. Hard cover, soft cover, you know. So author, cover, number of pages. What else?
You can have like journals, like I forget what they're called, scholar
Scholarly book.
journals.
Okay.
They're like written, I don't know what they're called. Sorry.
Yeah, we
Books.
all we can
Research.
say, yeah, we can, or maybe we can put that into the subject matter category if we don't want to decompose it too much, right? Okay, what else? So we have author, we have number of pages, subject matter, cover, type of cover. What else? Title, Brian Archer. Brian, title, that's correct. Very good. Title, that's very important, right? For a book, you must know the title, the author, soft or hard cover, and the subject matter. What else for a library? You know, if you need to, what else?
Are we talking about like writing a code?
Yes, because eventually when you write code, you have to define it first. You have
Because
to.
I want to say like if it's checked out or not, but
Yeah, that is good. That's good. So you will have in the library, you will say in stock or checked out, available or not, right? Availability is one of the characteristics. You see, if you have a regular book, availability is not part of it, maybe, right? It's a book. But for a library, availability is one of the characteristics. That's great, because now you can see why I said, okay, when you design an object, you have to think if it's relevant to your work, right? If this book belongs to you, it doesn't matter if you don't care about availability, it's yours. But since it belongs to a library, we are talking about a library book, then availability is part of its characteristics. Very good. Anything else?
I'm not sure
Anything
if it's
else?
been said yet, but like I'm thinking like fiction, nonfiction, romance, what type of genre it fits into.
Genre. Yeah. Okay. Genre, right? Yes. Very good. Anything else? Title, author. We have title, and what else?
so like nowadays, they have, when you go to the library, you can either check out a physical book or you can get an ebook.
Okay. Yeah, that's you see, that's another type, right? Is it ebook or is it physical hard copy? Yes. What is another characteristic? What is something else you must know about a book?
The edition,
The edition.
The
Yeah.
language,
The what?
the language,
The language. Yes. What else? ISBN. You should, right? That's very important. And publisher, that's very important. The year it's published, that's very important. And edition, that's very good. So now I'm so glad you were able to name some of the characteristics. That means you understand it, right? So how do you describe a book? Those are the characteristics. But do you have all of them? Do you need to put all of them in your object when you write this class? No. You choose the ones that are relevant to your work. It depends on where you use this book, as I said. If you use it in your for yourself, then availability is not an issue. It's always there. But if you use it in the library, then availability is an issue. Okay, very good. I like it. You did well. Okay, let's continue, everybody. I'm going to share my screen again, right? I cannot find my, it froze somehow. That's the attributes. Okay, now let's talk about these operations. For this chapter, we have two classes, unlike the previous chapters, everybody, right? Because this is brand new concept. So, okay, let's talk about the operations. With a student, what can you do? You can change the address, change the major, compute the GPA, and get the name, right? So those are some of the operations. And what are operations? Operations are just the methods. So that's called the behaviors. Okay. So for a rectangle, what can you do? You can change the length. You can change the area. You can calculate the area. You can change the width. With aquarium, you can change all these. Look at that. Computer. Let's take that off. Compute the volume. And for flight, you can change all that, right? So that's the behavior. An object. What is an object composed of? State and behavior. And state is represented by attributes we just discussed. Behavior is what that object can do. And that is represented by the methods. And you know method. So these are operations behaviors. When you write them, they become methods of your class. Okay, any questions? Okay, let me go back. Let's revisit this. Okay, so now let's think about it. Class, think of the word classify. So why do we call it a class? It's basically a group, right? A category. So that's why we call it a class, because you can classify these together. Okay. A class of things that have similar characteristics and similar behaviors. Every student has to have a name, address, major, GPA. That's why we say it's a group of things that have similar characteristics and similar behaviors. We refer to these as state, okay? An object is the, okay, so here, an object is the realization of this concept, the actual being of that concept. An object has state and behavior. So this is just a class, okay? It's a general concept. So you say, what is a student? Oh, a student has name, address, major, and GPA. What can a student do? A student has to take a test. A student can change his address, his major, register for classes, etc. So this is general to every student. It applies to every student. And then let me look at you. I think, okay. So then autumn. Autumn is one such student. So autumn would be an object. And all of you are objects because all of you share that same characteristics and behaviors. Okay, so you are an actual object. That's why we say, what is an object? An object is the realization of that concept. So what is the concept? This is the concept. And what is an object? You. You are an actual realization of that concept. Okay, that's what that means. On the right-hand side, okay, we discussed that. Any questions?
So the operations is that the behaviors?
Yes, operations are behaviors, yes. And when you define a class, they become the methods. Yes, operations are behaviors. Any other questions? Okay, so classes. A class can contain data declarations and method declarations and method definitions implementations. Okay, so this is a class. If this visualize it, this is a class. What does a class have? A class have to have these data. We call them data declarations. These are the characteristics, the properties of a class. Okay, and then you have to have methods. These are the methods. So what is a class composed of? Data declarations and methods. And we call these instance data. We call them instance data. They are the characteristics, okay, of a class. So a class is composed of declarations and data, instance data and methods. That is what a class is composed of. Okay, I will let you read this and then we will look at it. This, right? You read this. So this is talking about an example of a class. Just now we discussed student, aquarium, flight, etc. Now we have this example, which is called a die. So if you think about it, when you think about the dice, the singular form for dice, okay, you go to Las Vegas, you roll a die. So if you think about it, what is the characteristic of a die?
It's got numbers 1 through 6 on it.
Yes, yes, that is the top. When you throw it, you see the value on the top, right? That is why here it's saying consider a six-sided die, singular. Its state can be defined as which face is showing. Let's call it the face value, right? So that will explain, that will describe a die, the face value, what value it is. Its primary behavior is that it can be rolled, and let's call that behavior roll. Does this make sense to you, everybody? You know, think about the die. Okay, we have to know what face value it is. What is the value? And then how do you make it to have that value? You have to roll. That's the behavior it can have. Okay, so we represent a die by designing a class called die that models this state and behavior. The class serves as the blueprint for a die object. So you have this class. This serves as the blueprint, and then you can create as many die objects as you want. Okay, we can then instantiate as many die objects as we need for any particular program. The values of the data define the state of an object created from that class. We already discussed that. Okay, we have created a die object named good luck die. Its current state is 5, which is the face value. If you roll it again, the current state might be 6. If you roll it again, the current state might be 1. That is the current state, the value, the actual value of those characteristics. Okay. The functionality of the method defined, I have to find it here. The functionality of the methods define the behaviors of the object. We have the roll method in the die class, which is its behavior. Okay, that's the die class. So if you don't look at this slide, you just think about a die. What must we know? A functional die, what must we know? We must know what value is on the top, right? So what else do we know? Do we need to know? We don't really. Do we care how big the die is? No, not really. We just care about the top value. And that's why we have that as the characteristic. And what can a die do, really? What can you do with a die? You can roll it. That's it. That's the behavior. Okay, any questions? So the face value that represents the current value showing on the face is an integer, right? If you think about it, okay, the face value, what data type should it be? Int. The method roll would roll the die object by setting face value. So when you roll, you need to make sure it shows you a value. It changes the value of the face value. So by setting face value to a random number between 1 and 6, a class can have many operations methods. Not all of them will be used by a single program, but we want, okay, this is more of a maintenance issue, but we want to design it in that way so that it is versatile and reusable resource. So this means when we write a class, we don't want to limit ourselves to the current project. We want to think far beyond the current project. We want to think when this project will be expanded, you know, a system, right? It can be expanded. If you expand it, you need more behaviors and more characteristics. So that's what this means. Just think more about it, not just limit it to the current state. That's what it is trying to say. We will design the die class in such a way, okay? So here is the die class. What I want to do is I want to, let me go here. Okay, so this is, I put it here so that we can actually look at it and run it. I do have explanations there, but I will just explain it here. Okay, this is the rolling dice. By the way, you can always get these source code. I put it in the module. So if you go to modules and go to the very end, source code, right? It's here. So this has all the classes in the book. And you can download and you can download and use them to run your program to see, to understand it. So another thing I want to do is I also want to show you how to import. It is actually in the video, but let me just do it once. I don't think I showed you yet. So let's, this is what you do. Okay, let me go to, so you download it, right? You download it and you find it, okay? And then you go to your file. I will just show you how to import. Go to File and go to Import. And then because you download the file, it's existing. So you will select Existing Projects into Workspace. Okay, so you click Next. And then if your project is zipped, that's why I ask you to zip your file, your project, and send it to me. Okay, and submit. If it's a zipped file, you will click on this. If it's an unzipped, it's just a folder, a project, unzipped, you will select this. For mine, this is already, I unzipped them. So this is how you find it. Okay, let me go to, I need to find one. Downloaded course materials, source code. Okay, so you go there, source code, and different chapters. Suppose I want to go to chapter 5. Okay, remember these are unzipped. Okay, so you just click on the project folder and select folder. Okay. And that's the project, right? And you click Finish. And then you will see that project is here. Okay. That's how you do that. And if it's zipped, as I said, you simply go to Import and click Next and just select this. I don't know if I have, I think I have. Okay. So for example, I can select, this is a zipped file, right? I can click on one and open and then finish. Okay, so now we have this folder, this project. That's how you import a project, okay? So now let's look at this rolling dice. This is the project, this is this one. Okay, let's look at it. So let's look at this die. This is really the class we are talking about, right? We said we define a die class. And so you will say public class die, and you already know that. Curly brace, you know that. Okay, now here is something that's different. This is the final int max is 6. This is called data, instance data, right? But this really is utility data because if you don't have 6, that's okay. If you don't have it, it's still okay. You basically want to make it easier to reference, you see here, right? So can you simply say 6 without this? Yes. You know, so you can do that. This is not terribly important. That's what I'm trying to say. You can just change that to 6. But for good programming practices, if you can use a constant, if it's a constant, then you define it as a constant. Okay, this is the real data, face value, and it's int. And private, this is the key word you must use. When it says private, it means this data is not accessible outside of this class. No one would know about it. if you are not in this class, you don't know about this data. Okay, that's what private means. And public here, on the other hand, it means, oops, public means everybody can see it. It's public. Just like your profile, you have private and public. Okay, so that's that. And then this one is called a constructor. Okay, a constructor. What is a constructor? A constructor means you use this method to construct an object. Okay, so when you create an object, this method is called. So let's go to rolling dice. If you look at rolling dice, okay, so this is declaring a die object, just like what you did. You remember you can do scanner, scan, right? So it's the same concept, the same syntax. Class name, object name, okay, and you have two of them here. So now this is just another variable in the main method. This is another class. And then you do die1, which is that instance, this reference variable die1. Now you are creating the object. This is very much the same as you say scan is new scanner, right? System.in. So it's the same syntax if you look at it. Here it's die1 is equal to new die. And there is nothing in the parameter, there is nothing for arguments, because you look at die, it requires nothing. This method, it requires nothing. So when you call it, there is nothing. Okay. So this, when you do this new die, this is actually the method. If you think about it, this is the method, the constructor right here. So when you do that, the system will come here and execute this method. Okay. And so when it executes this method, it initializes face value, which is this variable, to 1. So my question to you is, when you do this, after these two statements, what are the face value? What is on top of the die? Are you listening to me, or are you, hello?
Yeah, we're here.
Okay, think about it. What is the top value for die 1? What is the top value for die 2? After you do these two statements. Think about it, okay? When you do this, you are calling which method?
The die.
The die method, and that is called a constructor. So what does that constructor do? It does that, right? So now, after these two call, what is the top value, the face value for die 1?
1.
1. What is the face value for die 2?
1.
1. Why? Because this is what it did, right? When you say new die, the system will come to this method. You know, when you call a method, the system will go to that implementation and execute the code. So it comes to this method and executes this statement. So after you do that, the face value for both of them are 1. That means they start from equal footing. They have the same face value. That's only fair, right? If you say, I want to roll a die, give me a die, give me a die, I want to roll it, I want to roll it, then they all start with the same state. Okay, so that's what that is. And then you do die1.roll. You are calling the behavior, the method. So die1, it will go to die, and it will go to roll. Here is the method. So what does it do? This is the row, right? The method. It will come here. It will do this. Math.random. This will give you 0.0 to 0.99999. Okay. Times max, which will give you 0.0 to 5.999, right? Okay, it will give you that that value, and you convert that to int. That would be from 1 to 5, and then you add 1 to it. That would be from 1 to 6. I'm sorry, 0 to 5. Okay, so I have it there. I don't need to write it here. Okay, so do I have it here? Oh, I don't. Okay, so let me explain it. So this part will give you a value of 0.0 to 0.99999. Okay, and then you multiply any value within this range by 6, it will give you 0.0 to 5.999, right? Etc. And then you convert that into an int. Okay, you convert that into an int, that will give you what? 0 to 5. And then you, after all that, you add 1 to it, right? Then the range will be 1 to 6. Okay, so this will give you a value between 1 to 6 and 6, between 1 and 6. And then you return that face value. That means you give it back to whoever called you. Okay, who called this row? This method. So when you do this, it will go to the die class and execute this method and give you back whatever this value is. And it also has changed the current state of the die class. So now your die has whatever this value is. It changed the current state of die. It also is giving you back. But however, you are not capturing it here. You are not printing it out. You are not assigning it to a variable. You are just letting it run. But no matter what, it changed the face value, right? Change the die. And die 2 you roll, it will give you another value. It changed it. Does that make sense, everybody? Do you understand it?
I think
Yeah.
I'm gonna have to rewatch the video, but somewhat.
Okay. Okay. Now let me ask you, what is die 1? Why do we go to the die class? When I go to the die class, why did I go to the die class to show you how it's it's implemented? Why? Because die 1 is what? Did you understand my question? I'm asking you, why did I say, okay, die1.row, let's go to the die class and look at that method. Why? Because die 1 is what? An object of
The
finish
die.
my
Is
the
it
die.
the die class?
Yes, yes, absolutely. That's correct. Okay, because die 1 is an object right here, reference variable of the die class. How do you know? Because here it is, right? It says die 1 is of die 2 is of die. So when you call any method using those reference variables, you are calling the methods in the die class, okay? And then system.out.println die1 plus die1 here. This is the object name, die1. When you use the object, yeah, go back and rewatch this video because there is a lot of information, new concepts here. Okay, so die1, when you use an object name in a system.out.println statement, it will automatically call this method, the toString method. So what does this do? This will, this integer toString, this integer, if you remember, is from chapter 3. It's a wrapper class, right? This wrapper class has a method, a static method. We talked about that also. A static method called toString, and it will convert any integer into a string. Okay, any value into a string. So face value is an int. Face value is an int, right? So it is converting it into a string and assign it to result. And then it gives back. When it says return, it means it gives back. It gives back that result. Whatever face value is, it gives back. So when you use the object name in an output statement, the toString method is automatically called. But you can also simply do this. You can explicitly call it. It's not necessary, but it's equivalent to this. So when you do this, it's equivalent to you are calling the toString method. Okay, so that we'll call the toString method. Now here, okay, let me do this. I will copy it here. Okay, what do you think it will print out for die 1? What is the face value of die 1 after these two statements, everybody?
Die 1 equals 1, right?
Yes. And die 2?
That's 1 as well.
It's 1 as well. Well, now we roll, right? We call this method. And when you roll, this happens. It gives you a random face value between 1 and 6 and give you back that value. So when you roll, you will have a random face value between 1 and 6. And now when you print it out, it will be whatever the current state is, whatever the current random value is. Okay. And then you roll it again. So let's just not do that yet. Okay, let's run it. Okay. So if you look at this, die 1, that's this one, is 1. Die 2 is 1, right? That's the initial state. And then you roll them, and it will generate a number between 1 and 6, and now it's 4 and 5. Let's call it again. And now it's 2 and 3. So it's random between 1 and 6, right? 1 and 3, okay? So it prints it out. Okay, just to illustrate, when you do this, okay, you are calling the constructor. I will put a system.out.println statement there, just so that you know this is what it is doing. So we will say, I'm in the constructor. Okay, let's run, and you will see this is the method it called. Right? I'm in the constructor. I'm in the statements. Yes. When you do this, it goes to the constructor. It executes this statement, set face value to 1, and then it executes this statement. Can you hear me? It says my internet is unstable. Okay, and then it executes this statement. Does that make sense to you, everybody?
Yes. Why? Oh, okay. I was going to ask why it did it twice. I'm in the constructor, but it's because there's die 1 and die 2, right?
Yes, exactly. You are calling 2. You're doing 2 of them, right? So
there's another question I have though.
Okay.
I don't understand why you do the die 1.to string.
Oh, I'm just saying this, you don't have to do it. Remember, this is what I said. That's why I said you need to go back and rewatch, because there is a lot of new concept. You don't have to do it. I'm just saying it's equivalent to that.
Okay, I gotcha.
Okay.
So
Yeah, go
you're
ahead.
basically saying that putting the toString is basically redundant of
Yes,
putting just die 1.
Exactly, it's redundant. You don't have to. A lot of students, they are good. They try to call the methods, but you don't have to. This will automatically call that method for you.
What's the difference between like I guess having a number string and just a number?
You are talking about here? Are you talking about here?
No, just like, well, yeah, just in general, I guess, because you got integer dot toString. So is that turns it into a string?
Yes, yes. Because your face value here, see, its type is int. So you cannot simply say face value. You cannot do that because face value is an int, right? You cannot assign an int to a string variable. That makes sense?
Yeah, okay, that does make sense.
That's why we do that. However, if you don't want to do that, you can use the string concatenation, you remember, and to concatenate this with a string. Now it's okay. Okay, so this is the simple way of doing it. And this is the more complicated way of doing it. But either way, it works. But you cannot simply do this because it's an int.
But why does it need to be a string? Why does result need to be a string?
Because, okay, that's a great question. That's a great question. Because this header, if you look at it, this is called the method header. Okay. It's return type. This is the return type. It says, I need to get back a string.
But like, isn't like any face of a die a value, like a number 1 through 6? Why would you turn that into a string?
Because the toString method is required to have a return type of string. That's just fixed. You cannot return anything else. For the toString method, this is an inherited method from the object class, which we will discuss way later. But this is a method from the object class, and it's already fixed. You must return a string. Otherwise, it's not the same method anymore.
Okay, I understand that, but can we do it? Can we do this same program without the public string toString class?
You are always to write the toString method. You always have to implement the toString method. If you don't, it will not make sense. Okay, let me show you. If you comment this out, okay, without the toString method, and then when you run, you will see this will give you only an object ID. It doesn't give you the meaningful object description. Okay, this is what it returns, right? This is the object ID. It doesn't make any sense. It makes sense to the system, but not you. So what does the, I think I didn't explain that yet. We haven't gotten here yet, but I'm glad you asked the question. So what does this toString method do? It really gives you a string that describes the object. So what does the toString method do? It returns a string of all the instance variables. Does that make sense? Because how do you describe a die, right? How do you describe it? You describe it using the properties. What is the property of a die? The face value. So you simply return the face value, and that's what this is doing. Does that make sense?
Kinda.
Okay,
So is
yeah.
the public string to string, like, is it making so that the user can read what the face value is instead of like what we're seeing right now?
Yeah. The toString method is basically give you a summary, a description of the object. So how do you describe an object once again, right? You use the properties, the attributes. And what is the attribute of die? Face value. So you return a string of face value. Okay, questions? You still don't quite understand it, right? Gradually, we have another class, so I will repeat all these concepts. But yeah, gradually, I think you will understand it. And here is something, okay. Constructor, if you look at the constructor, it doesn't have any return type. And you understand return type. We discussed this in Python, right? We discussed return type. So you understand that. For row, notice what it returns. It returns an int. So this public means this method is seen, it can be seen, it's visible. This is the method name, and this is the return type. So here it says if you implement this method, this is called the method header, the method header. So in the header, it has the required return type of int. Then you must give me back an int value. And this is the int value you are returning. And for this one, in the header, it says you must return a string. And so you must return a string. It must be a string. It cannot be an int. Any questions? Okay, let's go there. And you understand that, right? So now a row, we are calling the row method. Just to show you, this is how it works. I'm going to go into row, and before return, let's print out. Okay. And you can see it actually came here. I mean the row method. Okay. So when we do that, it will print out, I'm in the row method. Did I need, okay. So you can see I'm in the constructor, that's these two, right? And we print out die1 is 1, die2 is 1. That's because it initialized it to 1, right? The face value, okay. And so here, that calls the toString method, it will return this. Or let's redo it. Let's just say, okay, this is your toString method, right? I'm rewriting it, and let's call it. Let's run this again. Okay, look at the output, everybody, right? So this is, I'm in the constructor. You are calling the die method. And here, die1 plus die1, this is calling the toString method automatically. And so it says I'm in die1, the face value currently is, that's what I added, right? And die2, the face value currently is, that's what I added, right? And then we call the row method, and you remember I added this. I'm in the row method. And then die1, the face value currently is 5, etc. Does that make sense, everybody? Am I still?
Oh yeah.
Where am
You're
I?
still here.
That's okay. So after all those explanations, now you understand this, right? I hope. And let's, I will just decomment all these. Control-Shift-C, okay. And then we row again, and this we'll call the row method.
You're not sharing your
perfect.
screen
Yeah.
right now.
Oh, I'm not sharing. I need to share my screen. Give up privacy, right? Okay, so we are calling this row method again, and you understand that method. So it goes to this die again and just execute that method. Okay, here is another explanation to answer Tyler's question. Okay, so when you call row, remember it comes here to generate that. So if you look at this, right, we are rolling several times, not just once, several times. But we don't need to implement this several times. Every time you call row, it will come here and do this. If you write all this in your main method, guess how many times you have to write this code? Many times, right? So that's the benefits of writing the methods, because you can use it multiple times with one implementation right here, this one implementation, but you can use it multiple times. You see, I'm using it once, twice, 3 times. Okay, so that's the benefit of writing the class there, one of the benefits, and there are many. Okay, so this die2.setFaceValue, okay, and this method, where do you think this method is? Where is it?
In the die
In the
class.
die class. Why do we know that? Because we are using the object of the die class. We are using die2 to call this method. If this method is not in the die class, you cannot call it. Okay, because this is a die object. You can only call the methods in the die class. Okay, so let's go to setFaceValue. So setFaceValue, this is the header of the method. We talked about this in Python. Its return type is void. That means it doesn't give you back anything. And this is the method name, setFaceValue. And it accepts a parameter, which is an int. So this means if you want to use me, you want to call me, always give me an int value. Okay, so here you are calling it and you are giving it an int 4. Okay, so it gets that int and it assigns it to face value. So now your face value is changed again, right? When you roll it, it's changed. When you construct the object, it will be initialized to 1 for everybody. And then when you roll, it will change. When you set face value, you are changing it. Okay, and because its return type is void, you do not need to return anything. So that's why it has this. It doesn't have to. It doesn't have the return value. While we are there, let me explain this. This is public int get face value. This is saying give me back an int. So get face value. It doesn't have any parameters because you are just asking for a value back. And what does it do? It returns the face value. Give you back the face value. Okay. So after this statement, the face value would be 4 for die 2. Die 1 will be a random value. Die 2 will have a value of 4, right? And here it's getting the face value of die 1, which is whatever it rolled, whatever that value is after roll, it gets that value. And it gets the die 2's value, which is 4, right? And it add them together and print it out. It's meaningless, but it's just doing that to show you, you call that method, okay? And then it rolls, and remember this row return the value. So it gives you a value back, okay? If you look at this, row, remember it's value. So it gives you a value back, okay? That's why you can use it in this expression. So whatever value it returns, it will be added to whatever this die 2 returns, and then print out, print out, print out. So that's what this program is about. Okay, and now you can see, right? That's the output. Any questions? No questions? Okay. So I showed you where when you call each method, you will see that it comes to this method, right? Okay, another thing, so this is the class I'm talking about. We design a class, we decide, okay, a die only has a face value, and that's the characteristics. And what can a die do? It can roll it can change the face value, which is cheating basically, right? It can change the face value. You can get the face value. You can tell me what it is after you roll, and you can describe it. So this is describing the die object, the toString method. This is returning whatever the face value is. And this is changing the face value arbitrarily, right? And this is not cheating. This is really playing. You're rolling the dice. And this is constructing the die. That's the, those are the methods that are necessary for a class. Any questions? Okay, if you don't have questions, I will continue here. So this method is rolling the class, right? Now let's look at this method. Okay, we call this method the mutator. Okay, it's called a mutator. What does mutate mean?
To change.
Change, yes, change. Mutate means change, right? Mutants, the X-Men, the mutants, right? You change. So mutator, change. So this method is changing the instance variable. Okay, for a mutator, your return type is always void because you're changing it. You're not returning anything. You're changing the instance variable. We call this the instance variable. It's called instance data, instance variable, instance variable. Okay, okay. So you are changing it, and the convention is always to use set, which is a word, right, followed by the instance variable. So set instance variable. That's how you name your mutator. Your class should always have mutator methods for each in the instance variable. Okay, and mutators always accept a value that is the same type as your instance variable. Okay, so mutator does not have a return type. Its return type is void. It always accepts a value that is the same type as the instance variable you are changing. So we are changing face value. What's the data type of face value? Int. So you have to accept an int. Okay. And then you just have this one statement, right? And for this one, this is called the accessor. Okay, accessor method. Access, you get it. So access method will always use get. It will start with get, followed by the instance variable. Okay, so get face value. Mutator uses set, followed by the instance variable. Okay, so get face value, because you are returning the instance variable, your return type must be the same as your instance variable. So instance variable face value is of int. So you will return an int type. Your return type is int. And you simply return that face value. So, okay, a class should always have these things. A constructor, accessor, mutator for each instance variable, and a toString method that will describe returns of the instance variable. So, and then you will have whatever other methods you have. Okay, let's look at your constructor. Your constructor will always have exactly the same name as your class name. So die, that's the class name. Your constructor name is die. Okay. It can accept a parameter. It doesn't have to. And we will learn how to do that later anyway. Okay. It always has to be public. Okay. Your constructor has to be public. And there is no return type, not even void. So no return type. The function of the constructor is to initialize all instance variables. I added this statement here. It shouldn't be here. I'm just adding it so that you see we are executing this method. You don't have any other statements in the constructor. Your constructor is simply to initialize all instance variables. In our case, we only have one really instance variable, substantive instance variables. That's the face value. So we initialize it to 1. Okay, this is more of a utility variable, I would say, because you are simply using it. It doesn't really, if it's not there, it's still okay. But this you must have, right? So that's why I'm saying it's the essential instance variable. So there you have it. That's how you write a class. Do you understand it? Do you have any questions? Okay, so to write a class, you must have these parts. You must have instance variables. What are they? They are the properties, the attributes, and the characteristics, right? The characteristics that describe an object. We call them instance data. Okay. So you must have those declared, and those instance data must be private. And you saw that fine, private int face value. So those instance data must be private. That's one thing. And then for a class, you must have a constructor. And your constructor must be public. Your constructor must be public, because otherwise I cannot use you. I want to construct a die object, but you are not public. I cannot call you. Okay. So your constructor must be public, and its return type is void. It doesn't, no, I should not say that. It does not have any return type. Your constructor does not have any return type. And then your constructor must have the same name as what?
That's your class.
The class name. Your constructor must have the same name as the class name. Okay. And inside the constructor, what do you do? Initialize all what? Instance variables. Okay, so your constructor's function, what does the constructor do? Why do we even need a constructor? In your constructor, you must initialize all instance variables so that every object starts, they start at the equal states. They all have the same states. Okay, so every dice, when you create a dice, all men are created equal. And all dice are created equal. They all have 1 at the beginning, the initial state. So that's what a constructor does. Okay, and then you must have the accessor method. The accessor method is to return the value of the instance variable. Its return type must be the same as the instance variable. So face value is int. The get face value must return an int. And then you have the mutator method. The mutator method have the return type of void, okay? And its name must be set, followed by the instance variable name. So set face value. And then it must accept a parameter that has exactly the same type as the instance variable you want to change. So face value, that's the instance variable you want to change. Its data type is int. So your set face value method must accept an int. Okay. And you must have a toString method. Your toString method must always return string. You cannot change that method name. It must be toString. And you say, I want to implement my own method, print object or something. No, it should always be toString. And the return type is string. And what does it do? It will return a concatenated string of all the instance variables. Okay, so that's how you write a class. Any
So
question?
this is just for the, like, for a die, right? Like this is just for this
For
specific
everything.
example. For everything. Okay, so like if we were gonna do, like you were explaining earlier about a library with books and stuff, you have to have everything in here, the mutator, the assessor, the
Yes, that's how you write a class. So if you are to write a book class, you have to have instance variables, and we discussed them, right? Such as author's name, title, price, ISBN, etc. Those are the instance variables. For each instance variable, you must have an accessor and a mutator. And then you must have a toString method. And the toString method will concatenate all the instance variables, the title, the author, the price, etc., and return that string. And you must have the constructor, which is named what? If you're writing a book class, what's the name of your constructor?
the title of the book.
Okay,
The
now let
book
me ask
class?
you, if you are writing a book class, what's the name of the constructor?
Is it book class as well? Like, is it the name of the class?
Yes, and then exactly what is the name of the constructor then? If you're writing a class named book, what's the name of the constructor?
Just book.
Just book. Okay, you say just book. Autumn, do you agree?
Can I change my answer?
Okay, here is my scenario. If you're writing a class named book, the class name is book. What's the name of the constructor? Daniel.
Would it be library?
It would be library. Tyler.
Wouldn't it be book?
It would be book. Danny.
It would just be book as well.
It will be book. Isaac.
It'd be book.
Why?
I'm not really sure.
Not really sure.
Yeah.
Autumn.
Sorry, I'm reading over notes so I can figure it out because I'm not sure.
Okay. Gada. Yes. Heather.
Yeah, it's book, like the name of the class.
You broke off.
Oh, it's book, the name of the class.
Okay. Brian.
I would say book for the same reason. It's the name of the class.
It's the name of the class. Derek. Derek is there at the bottom.
Yeah. I was also say book because
Book,
the
yeah.
class.
It's the class name. Yes. So that's it, right? If you are writing a book class, the constructor's name must be book. Okay. Does it have a return type, the constructor?
No.
No. What's the, is it public or private?
That's
Public.
public.
Public. Your instance variables such as name or author's name, title, etc. Should they be public or private? I did not stress.
I'm gonna go with private.
Private or public, everybody else? Private. They must be private. Okay, your constructor, all methods should be public. Your instance variables must be private. They must be private. I know we are at the time, but let me ask you two more questions to just reinforce. Okay, so if you have a book class named the book, right? It has instance variables, name of the author or author name. What's the data type of author's name?
String?
String. And it has another type. It has another instance variable named title. What's the data type?
String.
String. It has another data. It has another instance variable named the price. What's the data type? Int or double,
Or
right?
double, yeah.
Double is more accurate. Okay, so if you have 3 instance variables, how many accessors must you have?
3.
3. Okay, if you have 3 instance variables, how many mutators must you have?
3.
3 for each one. Okay, for each instance variable, you must have an accessor and a mutator. How do you name your accessor? What does it start with? Accessor. You are accessing it. What does it start with?
Get.
Get, yes. So if you are writing an accessor for the title instance variable, what's the accessor name?
Get title.
Yes, get title. Okay, what's the mutator name for the title instance variable?
Set title.
Yes, set title. Okay, get title should return what type?
An int.
An int?
That's
No,
string.
wait. A string.
A string, because title is string, so it should return a string. What about get price?
It should return int or double.
Yes, a double, right? It always returns the same type as the type that is the same as the instance variable. Okay, so that's get, right? Let's go with set. Set. What's the name of the mutator for title? It's set title. What does it accept?
String.
A string. Very good, because string is the data type of title. So you will accept a new string to change this current title to the new title, right? Okay, and what's the return type for set? Void. It returns nothing because you are only changing things, right? You are not returning anything. Okay, last one. I don't want to let you go, but I know I should. Okay, toString. Think about toString. What's the return type of toString?
A string.
A string.
Always string, always string. Okay, toString, always string. And it does not accept anything. And so toString, what does toString do? If you have 3 instance variables, title, author, and price, what does the toString method do?
It returns a character string
It returns,
that represents the object.
say it again.
It returns a character string.
It returns a string of what? Tell me, of what? Title,
Yeah.
author, and price, right? It returns all 3 instance variables. Of course, you will concatenate them and you will make the formatting meaningful. But those are the 3 things you must return. Okay, I think we will stop here. And this is your homework. Okay, you have a lot of homework, but please watch the rectangle. I have a rectangle class. I have a video rectangle, and there is a video of dog. There is also a video of student. That shows you how to write a class. I want you to watch those 3 videos. And next time you come, I will ask you questions and we will write a new class. And then we will finish off the chapter. Okay, so please watch those 3 videos because we simply don't have time to do everything in class. Okay, and they are already there. Okay, everybody, I will let you go. You have a good day. Okay, bye.
Have a good
Thank you,
day.
Professor.
But,
See you. Bye.